Today we're going to look at one of the problems that we had on Friday. Someone has asked me to give them a little bit of help with this problem, so let's have a look at it first of all. Philip has these 5-digit cards. So he's got a 2, a 3, a 5, a 7 and an 8. He uses all of the digit cards to make a 3-digit number. That will be hundreds, tens and ones. And a 2-digit number. That will be tens and ones. He multiplies the two numbers together and gets 15,741. And they've helpfully set out the calculation for you so that you can see what we're doing. So we're multiplying a 3-digit number by a 2-digit number, and our answer is 15,741. Our job, right at the bottom we can see the question mark. What are the two numbers Philip makes? So we have got to find the numbers that will multiply together to make that. Not straightforward, but the skills that you have are there if you want to search for them. So we need to start thinking about the skills that we are going to use. First of all, we're going to use multiplication skills. Do you know your times tables? People who know their times tables will find this a lot easier than those people who do not. In fact, if you don't know your times tables, chances are you will not be able to do this. Learn your times tables. We're also thinking about place value and where position is going, but one of the skills that is going to be very useful for us today is rounding. So if you can round numbers to get an approximate answer, this will help you to choose and decide what order you are going to put the digit cards in. Okay, right, well, let's have a look and see how we get on with that. Okay, let's have a look at what we have now. So here's our numbers. I've just put them onto little pieces of paper so I can move them about and position them how I need to be. First thing that I want to think about is we're going to do a little bit of rounding, and we're going to go see if we can eliminate some of the numbers from particular positions. All right, so what we have got is I want to think about these numbers as just hundreds, all right, or just tens. I'm not worried about the ones at the moment. And I'm going to think about if we position, let's suppose that in the hundredth position, I'm going to have a 7. So this is going to be, we can think of it as about 700. All right. It's obviously not going to be that. It has to be 700 and something. It could be 732. It could be 782. It could be any of these, all right? But for now, we're not sure what they are, but it's a lot. If I concentrate on the hundreds here and the tens column in the second number that we're multiplying by, this will give us a rough idea of what sort of number we get. Now, so if I do 700 times 80, I know that 7 times 8 is 56. 100 times bigger, 10 times bigger. That will give me a number, 56,000, which is miles bigger than what we've got. So I know that the 7 and the 8 can't both be where they are. And even if I swap them round and have 800 times 70, that will still give me 56,000. So they are not going to go there. One of them might, but not both of them. So if we play about with some of the other numbers, we might, what we're looking for is to get a number that is close to 15,741, but not more than it. Okay, so because we were miles away, I'm now going to have a look and see, what about if I try the two smallest numbers? All right, let's move this out of the way so it's not confusing us for now. So 200 times 30. 200 times 30, that will give me 2 times 3 is 6, times 100, times 10 is 6,000. And that is quite a bit too low. So we're now starting to think about what can we be. So it can't be, it's not going to be 800 times 70. It's not going to be 200 times 30 or 300 times 20. So what else might we try? Okay, so we could continue having a look. Let's have a look. I've just had a thought because I know my times tables. If I do that, 500 times 300, 5 times 3 is 15, times 100, times 10, 15,000. Now that is very close. So can I possibly make something with that? What else can I get that's close? Oh, I've had another thought. I could do, if I take these ones out of the way, I know that 2 times 7 makes 14, and times 100 times 10, 14,000, which again is close. It's certainly a lot closer than this. Play about and see what other combinations you can get. Pause the video and try to get as big a list as you possibly can. Okay, don't just stop with the ones that I've got. See how many other combinations that you can get, which will give you a rough idea of where you are. So pause the video now. Okay, have you had a chance to have a look? Well, this is what I did. I went through all the digits and I've seen what all they can be multiplied by. So 2 can be multiplied by 3, or the 5, or the 7, or the 8, and that will give me 6, 10, 14, or 16. Remember that these are hundreds times tens, so each of those numbers, when I put them in position where we were talking about put them, will give me 1, 2, 3 extra columns, because they will be 1,000 times bigger. So each of these, when we look at them and we compare them with our numbers, oh, look at this one. This one is too big. So I can cross off 2 and the 8 as one of the permutations that we can have. Because if I've got 200 times 80, it's going to be at least 16,000. If I have 800 times 20, it's going to be at least 16,000. So it can't be that, because it's too big before you even add it, put in all these extra digits. Okay, so again, we can come down this one. 3 times 2, 3 times 5 is okay, but I can get rid of that one. I can get rid of that one for the same reasons. Coming down to 5, when I'm multiplying by 5, first 2 are okay, but 5 times 7 is 35, so 500 times 70 will be 35,000, or 700 times 50 will be 35,000. So that one's going to end up too big, and that's even bigger, so that's going to end up too big. Coming down here for the same reasons, this one might be okay, but this one, 7 times 3 is 21, so that can be 21,000, 35,000, 56,000. So those are all going to be too big. Coming down here, oh look, none of the ones with an 8 in them actually work. 16,000 this would end up as. 24,000, 40,000, 50, they're all bigger than 15,741. So I can cross off all those. So I know that the 8 cannot go in the first position of each of those numbers that we're doing. That's useful. And look how many we got left. There's not many positions that we've actually got left. We've only got 1, 2, 3, 4, 5, 6, 7, 8 different permutations. Okay? I'm now going to show you how we can get rid of some more of those permutations. Okay? So let's have a look and see what we're going to do now. Right, so we're back to our calculation that we've got to try and work out. So we've got all these 5 digits that we need to try and put into the correct positions. Now, the thing that I have noticed is that, look, odd number. Or if you multiply numbers together, there is a rule about what sort of answer you get. If you multiply an even number by an even number, the answer is always an even number. Think about it. If you think about any even number, like for instance, if you had 4 and you multiply it by 6, both of those are even number. Our answer, 24, is an even number. All right, take my word for it, that always happens. You can go and check yourself if you're not sure and you want to prove it to yourself, but you look at your times tables, anytime you multiply an even number by an even number, you get an even number. If you multiply an even number by an odd number, you always get an even number answer. And again, you can check that. So for example, an even number could be 8. Your odd number could be 5. Your answer, 40, is an even number. That always happens. And again, you can go and check that yourself just to prove it to yourself if you're not sure. So we have, and even if you swap these round and you have an odd times an even, you should know that 8 times 5 is the same as 5 times 8. You still end up with an even answer. Okay. The only other combination that you can have is an odd number times an odd number. Now, an odd number multiplied by an odd number will always give you an odd answer. And again, if we have a look at it, let's pick an odd number like 7. And if we multiply that by another odd number, 3, we get 21, and 21 is an odd number. Whoa. Now, if we have got an odd number here, that means that both the numbers that we are multiplying together must be odd numbers. Must be odd numbers. That tells us that the number 8 and the number 2 cannot be in any of the ones columns. Cannot be in any of the ones columns. And then if we put that together with what we found out here when we did this, and we found out that the number 8 cannot go in either the hundreds column of the 3-digit number or the tens column of the 2-digit number, there is only one place left for this 8 to go. Where could we put it? Let's have a look. So, where's that 8 gone? Here it is here. Where can it go? Can't go into the ones column because that will give us an even answer. And we want an odd answer. So it can't go in there or there because both of these digits have to be odd. From that first part we do, it can't go here and it can't go here because that will give us too big an answer. That only leaves us with one place. The number 8 has to go there. Has to go there. Now that's a few steps that we had to think about using our knowledge of numbers. If you're confused, go back and have a look at those bits again to see how we did it. Go back and have a look at what we did with all this. All right. And then go back and think about what we did with the evens to make evens, odds and evens to make evens, odds and odds to make odds, and that helps us to get the information we need to say that the 8 can't go in here or here, and it can't go in here and here, so it has to go there. So if you're not sure, go back and look at them again.
Right then, the next thing, what I've got is I've got a calculator, and I'm going to use the calculator to show you something that will help us decide what we are going to put into the ones columns. I'm going to show you something that happens when you multiply two numbers together. Okay, so let's suppose that we are going to multiply these two numbers together. Let's suppose we're going to multiply the number 34 times 57. Okay, so let's do 34 times 57. So let's type it in. 34 multiplied by 57, and our answer equals 1938. Now, how is that going to help us? Well, what I want you to think about is look at the ones columns in each of these numbers. In 34, the ones column is a 4, and the ones column in 57 is a 7. Now, when we multiply 4 times 7, if we multiply 4 times 7, what do we get? It equals 28. Look at that ones column in the answer, an 8. Look at the ones column in our answer here on the calculator, is an 8. 34 times 57 is 1938. 4 times 7 is 28. What I'm trying to say is that every time that you multiply together, as long as there are no decimals, our ones column, when we multiply those together and get an answer and just look at the ones column of our answer, that gives us the ones column of any multiplication that has those two digits in the ones column. Let's try again. Let's try another one. Let's clear this, and let's do an even bigger number. Let's do 7, 8, 9, 6, 5, 4, and let's multiply it by 3, 8 equals. Okay, so those two numbers, 7, 8, 9, 6, 5, 4, ends with a 4, and we multiply it by 38. So that's got a 1. That's got an 8 in the ones column. If we now think about 4 times 8 and we multiply those together, 4 times 8 equals 32. Look at that ones column. Look at the ones column on the calculator. All right. Now, I'm not going to show you any more. You can try this if you like. Get yourself a calculator and have a go. This is always the case. This will always happen. Now, that helps us with our question. But how does it help us? Let's go and have a look.
Okay, all right, so now that we've used that with the calculator and we've learned something, it can help us to think about what is going to go here and here. We know that the two digits that we multiply must have, if you multiply those digits together, they must have a 1 in the ones column. So let's have a look at all the different combinations that we can have. There they are. And straight away we can say 2 times 3 is 6. So it's not going to be a 2 and a 3 in the ones. A 0, a 4, 7, 15. Oh, look, 21. So there is a potential. And up here, now there's no ones in there. The only other one is this. So, ooh, we now know that in the ones column, we have to have a 3 and a 7. Can go either way, in either order, but we must have a 3 and a 7. So let's have a look and sort that out. So in this ones column over here, one of those numbers has to be a 3, so it could go there. The other number in the ones column must be a 7. Now they could go the other way around. It could be something in 87 times something 3. It could be either way, so be aware of that, but we at least know that they are there, which means in this column here it has to be the 2 and the 5. Okay, so you have now got a few calculations that you could try out to see which one gives you that final answer. We now know that there's only a few answers. We could have what we've got there. We could have 287 times 53. That could be one of our answers, or one of our calculations it could be. If we swap these two around, we could also have 283 times 57. So we could have that as one of the calculations. Now the other two possibilities that we could have is by swapping these two around. So if we have 580 something, it could be 583 times 27, and we could then swap those around as well, and we could have 283 times 27. Okay, so you've now got these four are your potential answers. All you need to do to work it out now is to decide, well, to try them out. And when you get 15,741 as your answer, you will have found the correct one. I hope that helps you with it. Let me know if you did, especially the person that asked for me to help. Good luck with that. And remember, there is always a way to solve it if you use your number facts, or you use the knowledge that you already have. You just need to dig it out of your heads. Most of the things that I talked about here were already in your heads if you have been remembering them. Okay, so good luck. Let me know how you got on.